You can just add extra. Alright, let's talk through some of the details with this one. This is an important review. Come on, dude. You got a nice solid 66, and you can bring it up with a retest. Come do a retest. Alright, and that's after putting your Matthew stuff back in.
Oh yeah, my mom used to sign me up for retest.
She needs to look within the, it's on the first page of the newsletter. It's just, I think there's literally the word link, and I hyperlinked it, so you just click on the word link, and it takes you to the form.
Okay.
Yeah. Okay. So let's look at this, guys. We got to move a little bit quicker with this because we only have so much time. Literally, this is the last week of learning that we can do. And we got a couple of things that I need to address and cover to help us get started. To actually start recording. Yes.
Good morning.
Good morning. All right. So we're starting to notice or remember a couple of things. So we got k of x is equal to negative 2x squared plus 13x minus 15. So for those of us who have to take the final, there's a couple of features that we should notice. And please hear me clearly on this. Yes, second degree polynomial, which means it's a quadratic, which means on the graph we're going to see a parabola, which means, well actually that's all I was going to say with that. So those are things we want to notice right away, but those aren't the features that I'm referring to. Desiree, good morning. I don't know how I missed you earlier. Did you just walk in? Did you have a pass? Okay. Let me mark it. Sorry. Find that. All right. But you want to do this, right? And there we go. So, looking at this quadratic right here, can someone let Hayden know, please? What are the features of the parabola that I'm referring to? And there's two features, Grace, that we should be looking for right away. Concavity is always one we want to look at. And then based on, hey, which form is this again? Standard form. So based on standard form, what should we immediately be able to see? The y-intercept. If you didn't know that, pay attention. How do we always find a y-intercept? What key thing is true about every y-intercept that has ever existed? X is equal to 0. We got to know that. That's not something we should be able to question. We got to know instantly, hey, x is equal to 0 for y-intercepts. Which means, what is this going to become when I substitute 0 in? With 0 squared? 0. So that whole thing becomes 0. What does this become? And so when we look at standard form, the x value is 0. What's the y value? Negative 15. Okay. 0 comma negative 15. That's my y-intercept. I bring this up because every assessment that we've had on quadratic functions, one of the things was, hey, here is a graph that has no scale or anything like that, but hey, what equations could go with it? You need to be able to notice, hey, it's a negative y-intercept. 0 comma negative 15. That's something that will show up on the final. That's also something you should just know in general. Concavity, someone already brought that up. What is the concavity here? Down. Because what is negative? The leading coefficient, the A, right? So that leading coefficient tells us about our end behavior. It tells us about concavity for parabolas. But now is when we get into the things that are important for helping us tackle a later unit on solving quadratics. Does anybody remember how to find the vertex? Okay, so x is equal to? Right, we got to remember that. So this is something that's going to help us on the linear, exponential, and quadratics unit, those three functions. This is also something that's going to help us in solving quadratic equations. Right? So remember, this is a review time to help us prepare for the final. These are good things to be taking notes on. So the vertex, that's the x value of the vertex. That's how I calculate h. And so what is the opposite of b? So a, b, c. The opposite of b is negative 13. B is a positive 13. Right? Sorry, I couldn't hear what you said, Miracle, so I wasn't trying to ignore you, I just couldn't quite hear.
Oh, no, I was
I got you. So B is the 13, the opposite of B is negative 13. Divided by, what's 2 times negative 2? Which gives me a negative 13 divided by a negative 4. Notice, I'm not necessarily putting this part in the calculator. A lot of us are making mistakes when we put it in the calculator. But we can do 2 times negative 2, right? The one last thing is, what's a negative divided by a negative? Positive. Now, you should be able to find the vertex here, but I will point this out. If I'm trying to find a 0, what's the only method I'm probably not going to use? If I'm trying to find a 0, probably not going to convert to what form? What are we trying to find right now? Vertex. What would I probably not use? Vertex form? For what reason? That's a fraction. Right? Do you want to deal with fractions? Personally, I don't. Okay? And so that's something to keep in mind, right? So what's going to be the easiest path to be able to find zeros? Well, that's not going to be fun. Right? I'm not going to go with the vertex form. I'm probably not even going to finish finding the vertex here. The h is 13/4. How would I find what the k is for that vertex? Substitute it in. Remember, your x, Hayden, what's another word for the x value? Starts with an I. Not an inverse. Remember, that's what undoes things, right? But it does start with an I. It is an I-N, and then a P. So we got to know this, guys. We got to know. It's an input, right? So we're going to substitute it in for x, right? Don't make it complicated. You can use the calculator to do this. Literally, right? 13/4 would be substituted in for x, and I would just use a calculator. But we would get a nasty number. Whoops, 13 times 13/4. So make sure you check yourself as you substitute in. That's how I catch myself a lot of times making mistakes is I look back up and I was like, ooh, I'm missing my 13. And then x is 13/4. And so I go back in and check. That's something that's hurting a lot of us is we're not slowing down and going back to the original. Okay, I got my negative 2. I got 13/4 squared, 13/4 minus 15. I check myself. You got to move quickly, but you got to move efficiently. Check it. So there's my input, and then whatever we get out of that is my output, and that's going to be my vertex. I never said I wouldn't. I said, what's the only method I would not use? I would personally not use the vertex form. Now, do I need to re-explain anything here about finding that y-intercept, finding the concavity, or finding the vertex from standard form? Or do you have any questions about that?
So you said you really use vertex.
Right. Because what I can do is I can convert this, right? So k of x equals negative 2, that's my a. So a times x minus h squared plus k. I now know that my h is 13/4 squared plus whatever k is, but I know that k is going to be a fraction. So do you want to solve an equation with some nasty fractions in there? So that's the only one I wouldn't use. Does anyone remember what group Haley was in? Group 5? Thank you. Okay. So that's the only thing that I wouldn't do. Traylon, you were asking that question. So yeah, because remember, and I will remind you of this, and we'll do a practice problem with this in the future. If I have the vertex form, how am I going to find my zeros? I'm going to have to use what? Not if I have vertex forms. Inverses, right? Do you want to use inverses with fractions? Do you want to add and subtract with fractions? Do you want to take a square root of a fraction? Right? So those are things that you would want to consider, and I personally wouldn't want to. Does that make sense? Okay. So do not forget, if you have vertex form, you definitely want to be using the inverses. Now, that's not the method I would recommend here. If I want to find zeros, by the way, what's another word for zeros? X-intercepts, right? Remember, we got to connect that vocabulary, because if I ask you for an x-intercept, what should you also immediately think of? Well, yes, we're trying to find inputs, but we're trying to find zeros, which is when our output is... Yes, ma'am? Okay, so hold on. Listen, if I want an x-intercept, Miracle, what's another word for an x-intercept? Starts with a Z. If I want an x-intercept, I'm also, the other word to think about is a zero, because the y value is 0. And so 0, right, my output, my y, is equal to negative 2x squared plus 13x minus 15. We already said no to vertex form. Naisha, you said that you would use what here? So we might want to check the AC method of factoring, or Ethan, you said we could use the quadratic formula. Either one would actually work here. Remember, AC method of factoring literally comes from taking A and multiplying it by C. What's negative 2 times negative 15? 30. And then I need factors of this that do what? Anyone know factors of 30 that add up to 13? Right? So 0 equals, and so remember, I'm just going to split that up so that I have a total of 4 terms. Negative 2x squared plus 3x plus 10x minus 15. What do these first two have in common? Now I've got a 2 and a 3, that's nothing in common. I've got 2 x's though. So I'm going to factor out an x and be left with? Don't forget your negative. So negative 2x. I will say we could have factored out the negative. That might have been a good idea. Doesn't really matter. But if I factor out the negative, then what would I be left with here? Positive 2x. Say again. Minus 3. Notice I factor out a negative, so that positive becomes a negative, and I factor out the x, so we don't have an x there. What do 10x minus 15 have in common? What can I divide both of those by? You can divide both of them by 5? So what is 10 divided by 5? 2, so I'm left with 2x. What's negative 15 divided by 5? Negative 3.
Wait, how do you get that fire right there again?
What can I divide both of these by? That's my greatest common factor. Does that make sense? Don't forget, I also want these to match. So I knew that I wanted a 2. 10 divided by what gives me 2? 5. And so I got to check to make sure it correctly factors out of here as well, but it does. I will point out, if I had factored out a positive x here, this would have been a negative and this would have been positive. You see how close these are? That would have been a hint to me, hey, maybe factor out a negative. And so these two signs change. Ah, now they match. From there, what can I do? Say again? I'm not crossing them out. What am I doing? They both have a common factor of. So what I'm really doing is I'm factoring out the 2x minus 3 tonight. And I cross it out just to help me focus my attention. Once I factor that out, what am I left with? Now what am I going to use? Zero product property. Because, and this is something a lot of us have missed time and time again, it's not just, hey, use the zero product property. We are multiplying two things, and their product is what? What is the only way that I can multiply two numbers and get 0 at the end? If one of the multipliers is 0. That's the core of that zero product property, is if I am multiplying by two numbers, the only way I get 0 is if one of those numbers is 0. So 2x minus 3 would equal, what would 2x minus 3 equal? 0. And what would negative x plus 5 equal? And I have faith in your abilities to finish solving for x. X would end up equaling, if you want to try this on your own later, 3 halves and positive 5. Those are your zeros, and you can convert those to x-intercepts. Okay? So, factoring is a really strong strategy. It is an expectation for the final. I meant to print out a print out the list of topics I have for you. I'll make sure I print it out before tomorrow and give you the list of topics tomorrow for the final. Last detail I do want to remind you of, Ethan, you brought up which form, or which method again? Quadratic formula. Guys, the quadratic formula, the beauty of it is, you just have to memorize the equation and substitute stuff in. What is the quadratic formula? X equals? So remember, it starts out just like the vertex from standard form, right? That negative b, and what are we dividing everything by? Right? There's that negative b divided by 2a. We just have to account for the zeros, so plus or minus.
Minus 4.
And it's just a matter of substituting a, substituting b, and substituting c. Please be careful. And I'm going to show you an instance from the understanding check where we do not pay attention to details, and I need us to start paying attention to details. I've said this time and time again. This entire numerator is being divided by 2a. So you need to simplify everything in the numerator before you divide by 2a. But x would end up equaling negative 13 plus or minus the square root. Remember, I always put my 13 inside of parentheses. Minus 4 times a is negative 2 times c, which is negative 15, all divided by 2 times negative 2. If you simplify that correctly, you will get these same exact zeros. It's just substituting into that formula. That is a fantastic method to solve a quadratic. And I will remind you, with factoring, that only works with rational roots, right? Fractions and whole numbers. However, the quadratic formula works for irrational. It works for imaginary, the whole nine. So the quadratic formula is a great strategy to always be able to pull out. You can't do the plus or minus piece, which is why I always recommend substituting. And sometimes if you get a negative under the square root, it will not be able to do the square root for you, but you can do everything else in the calculator. Well, what I would do is I would just substitute all of this in. You would end up with 9, so substitute all of that in. And then you can use the calculator to simplify that, but I would point out the square root of 9 is something we could know, right? And so negative 3 plus 3 is negative 10 divided by negative 4. Negative 13 minus 3 would be negative 16 divided by negative 4. And if you simplify this, I made a mistake somewhere, hold on. Where did I make a mistake? Oh, right here. That's 60, that's 120. That should have been a 49. That's what I get for rushing. That should have been a 7. Negative 13 plus 7 is negative 6 minus b. And so then I get positive 3 halves and a positive 5. Just like from the factoring method. Okay. Sorry, that was a lot of review, but that covered essentially 2 whole units worth of 1.5 units of instruction. It did not review the linear or exponential, but it covered most of the stuff from quadratic functions. It also covered most of solving quadratic equations. So if you needed help with features of quadratics, this review, this 20 minutes or so, is a fantastic part of the video to go watch. If you needed help with solving quadratic equations, again, I skipped some steps because we reviewed it over and over again, but great 20 minutes to watch for factoring and using the quadratic formula. Okay. Questions before we continue? All right. I need you to have your understanding checks out that I passed out at the beginning of class, because the very first thing, actually the very first thing is this. No one signed up for to do the test after school today. And my wife needs me to pick up my son as a result for something for her to go do. So no tutoring after school today. So softball is gone Wednesday at some point, not sure when, not sure what the policy is going to be. More than likely, it's going to affect our learning on Thursday to some degree. I don't know what the plans will be, but we have to test either Thursday or Friday. I would prefer it to be Thursday so that I can let you know on Friday if you're exempt or not. Most of you should know roughly if you're going to be exempt, and I can tell you roughly where you will be on Friday if we have to take the test on Friday. But notice, instead of taking a day to review, we're taking essentially 2 weeks for 20 to 30 minutes every single day to review. So more spread out on the review for the exam and to help you retain these ideas. So we're not going to have a whole day to review unless we test on Thursday. But may mean the test is Friday, may mean that I have to email you over the weekend to let you know if you're exempt or not. My goal is, if we take the test Friday, to get the test completely graded on Friday. Probably work on it until I give it to graduation. Unfortunately, that's just where we are. Yep.
How long did we spend on that test that they did our test for?
You have up to 90 minutes. So up until that. So if it doesn't take you that long, it doesn't take you that long. But we have as long as the class block was.
So like I can start it tomorrow morning and finish it in the rest.
Yeah, something like that. Yeah. And that's something I put in there. If you do it, start in the morning, you won't have enough time to finish it in the morning. We'll have to do something else. But it should also go quicker with having seen the test once and seeing a different version of it, but very, very similar. Right. Quick notes from understanding check and inverse functions recap. What is math? We'll talk through that one before we get to lesson 2 out of the book. So you can go ahead and get your book out. We should be somewhere around later than that, M3-100 something. Sorry, just taking the book like this. M3-108. Oh, 110. M3-110 is where we were. Okay? So M3-110 out of the book. And then we'll get quickly into lesson 3. The whole point of all this is the inverse of the exponential function. Trayon, I think you asked if we're going to learn something new. And the answer is yes and no. It's building on the inverses and learning about the inverse of an exponential, which is not terrible. Okay, first things first, ma'am. M3-110. I need you to check your graph again on numbers 1 and 2. Do you see how I have circled this point right here? Is there an arrow? No, there is not an arrow. Do not have an arrow because that is not mathematically accurate. Notice this is much like the what from the parabola. That's the what? Yep.
I don't know.
Were you here Friday? So I'll have to use your test to assess these skills. We went directly over this after we finished the understanding check on Friday. So I would watch it, take notes, come in and ask questions if you need to at some point to learn. But please notice, this point is equivalent to what from the parabola? Thank you. Say it louder, Naisha. That is the vertex. Notice how we restricted the domain. Do we have anything to the left of the vertex? So should we have anything beyond this vertex? make sure you do not have an arrow there. I saw countless people have arrows even though we were not supposed to, and I directly talked about it. Please also make sure you have a table. I could not believe that we went over this and we talked through it and we didn't even have the tables. And I'm going to show you a couple of responses on number 4 or 5, which is number 5, where we've got to pay attention. Like, I know it's only a week left, but this information really does matter. The concept of inverse functions is one of the most important ideas that's going to come out of your Algebra 2 class that you would have to carry into future classes. So here was my response for number 4, or 5, sorry. With number 5, and we're going to stay here a little bit longer. With number 5, 1, what was the detail? Sorry. What was the detail that I started every single class block for 5 days straight talking about for inverse functions? It's a reflection across y equals x and the inputs and outputs transpose, the x and y transpose. And not only did we have that at the beginning of every class block, we then also talked about it multiple times throughout the class block. Okay? Guys, we've got to learn to retain information. Even if you did not take the time to study, that's something that you should know. Now, I need you to also look at these unupdated answers after we directly went over it. There's a lot of good information here. Specifically, like there's a lot of good information here, especially the inverses or reflections. But does anyone see anything that is completely missing that is a key idea to make sure that we have in the future? Even after updates. Okay, so maybe some about information about vertical and invertible. There's a little bit more though. Even this detail about inverses or reflections is missing what? Across y equals x. Guys, it's not just any old reflection. We got to update that. It has to be across y equals x. What about your inputs and outputs? They have to transpose. Do we have that detail? No. Now, I will say, like, there's a lot of extra details here. If we had had all that information, this could have gotten up to a 4+, right? Functions have zeros, yes. Be aware of not showing possession there, right? There can be more than one function, such as quadratics. Please note this is something conceptually to update. They're not broken into 3 functions. A quadratic function is a quadratic function. They're broken into 3 different forms, right? Vertex, standard, and factored. Inverses are operations that you can apply to an equation or a function, but what we had talked about day after day, functions and their inverses are those reflections and the transposing. Right here, there is good information, but what's missing? It says it is the opposite values, which goes through the line y equals x. They transpose and reflect through y equals x. What's missing? So it's got reflections. So even degree and odd degree, yes, but so let me clarify. What I'm looking for is the most important key idea, that first sentence from my answer. Okay, it has the y equals x. The inputs and outputs what? Transpose. When we say transpose, we got to talk about those inputs and outputs. We need to be careful about it. And the reason there's a C plus right here is it says it is the opposite values. Mathematically, what is the only thing we mean by opposite? They switch the sign. Whether it goes from +3 to -3 or -3 to +3, let's make sure our iPads are up. So that's a conceptual misunderstanding. We got to pay attention to those kinds of details. You guys, if we're not paying attention to details, that's why we're struggling. For a lot of us, we're just not even updating our notes or updating our answers. We've got to fix that.
Mr. King,
Yes, ma'am.
what does CT do?
Plus, C plus. The C, remember, stands for a conceptual misunderstanding, meaning that you misexplained something. A D plus means that you're missing important details to varying degrees, right? If it's a 3 or a 3 plus, you're missing fewer details, but that idea of transposing my inputs and outputs. I will also say we need to be careful with our language. We gotta quit saying they, we gotta quit saying it. It and they is vague. Functions and their inverses, or functions are reflected across y equals x to get the inverse. To get the inverse, the inputs and the outputs transpose. Notice there is no it, there is no they. That is a vague explanation. We gotta be precise with our language. And then again here, no updates. Functions are what creates the lines on the y and x axis. Their inverses are the transposed version of the function. We're using buzzwords without thinking through and explaining them completely. We've got to, one, learn this information, but again, guys, this is after we went over it. Huh?
Yeah.
That doesn't bug me. The ideas are what matter to me. What bugs me is we directly went over this, I put the answer on the board, and we still did not update it. Guys. And it's not calling him out or anything. Like, when I look here at Jacoby's, he wrote the entire information out. Like, he had time to write all of it out. And some of us didn't even take the time to update. We have a week left, it's like there's only so much that we can do in our learning for this week to change our grades, hopefully pass. However, that's something you have to fix moving forward. I hate that we've had teachers with such low expectations of us that we've been able to get through with that, but guys, we gotta pay attention to details. We've gotta learn how to learn and be precise with our language. We've gotta be precise with our understanding, because you're capable of amazing things. I don't have low expectations of you because I know that you're capable of more. Is it uncomfortable? Yes. Does it make us work harder? Yes. But you will never reach your potential unless you get pushed. Your football team is never going to win stuff, Jamarcus, unless coach pushes us, right? Same with baseball. We're not going to win as much unless coach pushes us. Same with softball. And your brain is a muscle. Muscles have to work out. They have to work hard to grow and get better. We've got to embrace the challenge. We've got to embrace the work. It's not all sunshines and unicorns. So, with all that being said, math is the study of what? Patterns and relationships. We're looking at exponential functions, and we're going to get into their inverses today. What we're about to learn about is an important new number. What's an important number that we have learned that doesn't really appear to be a number at first? I was what? Nope. Square root of -1. We got to remember that square root. Remember, because here's the thing. If you say I is -1, what does I squared become? What is -1 squared? Just 1. That doesn't help us because we already have that. But if we do the square root of -1, what is the square root of -1 squared? -1. The whole point of I is that when I square it, I get a negative. What's a number that you learned all the way back in middle school that did not appear to be a number at first because it's got a weird symbol for it? Which one? Pi, right? Pi is actually a Greek letter, right? So if you go to ancient Greece and you look at their letters, you'll see the symbol pi there. If you go look on UA's campus at the fraternities and the sororities, you will see pi show up time and time again. It's a letter. But we use that letter to represent a really important number, 3.14159, . We use pi because pi is an irrational number. That decimal never terminates and never repeats. We are learning about a new one today known as the natural base, and it is the number e. And so, last week we finished up this table in this class, I believe, right? We did the domain, the range, the asymptotes, intercepts, in behavior, and intervals of increase or decrease on page 110. Here were the notes that we took, right? Notice this one was an exponential what? Growth, right? Notice and remember we talked about it as when the base is greater than 1. Because if you're multiplying by something bigger than 1, it gets bigger and bigger and bigger. And so we got this domain, we got this range. I'm going to talk about this asymptote again in just a second. Pay attention to your end behavior again. You always need left-hand side and you need a right-hand side. And we're going to talk through that in a second. This asymptote, what did we mean by an asymptote of y equals 0? Okay, why was it the x-axis though? Anybody remember? Avoiding questions because we don't want to think. Yes, Mr. Kenny? Guys, we should have had a little bit of a note here about an asymptote. In fact, I see it on Grace's page. What was it? The line the function approaches at infinity. Notice, here's a line. Is that function approaching that line at infinity? And notice that key language of approaching. Does it ever get there? No. And that's why we did not have an x-intercept. The asymptote is y equals 0 because what is the y value of the x-axis? 0. And we saw a similar thing here with the exponential decay. We saw an exponential decay whenever the base was between 0 and 1. Don't forget that. Remember, if the base is equal to 1, what type of exponential function is it? Do what? It's just a line. So what type of exponential function is it? It wasn't 1. Right? If it's a line, it's not exponential. What about if the base was less than or equal to 0? Say again. Say it louder. There wasn't anything there for b equals 0, and when it was less than or equal to 0, remember how it got like really funky and started bouncing back and forth? So the base could not be less than or equal to 0. So those are some key ideas to keep in mind there. Last thing I do want to point out, let's say that my exponential curve looks like this. Does anyone know what the asymptote would be here? Is it still y equals 0? Y equals 3. It would be 3? It wouldn't be 3? Why do you think it's 3? Jose? So just tell me why.
Because that line right there.
That line right there, what? What's it doing? What's it approaching? 3. As x, notice as x goes towards what? Infinity. Y goes towards. So as we go out to an infinity, is y approaching 3? So what's my asymptote? Y equals 3. That's it. It's a line that the function approaches. And notice it is y equals 3 because if I look right here, that is 1, 2, 3, 4, negative 4, comma 3. This point is negative 1, comma 3. This point right here is 0, comma. So every point on that line has what y value? That's why we call it y equals 3. Shania, you with us? Hayden? You alive over there? Come on, Shania. We got stuff to learn. Come on. Can someone help Haley out while I go to the next slide? So, for this recap, what questions do we have? Come on, Marshall, focus. Haley, come on. Jalen? Too early in the day to be this asleep.
What do you mean? That's what time you're supposed to be sleeping.
It's 8:45. How do you stop falling asleep?
When do you wake up?
Oh God, 40.
4:50.
4:50 in the morning.
I don't work out every morning. I'm there by 5:30.
Working on the evening.
Is it?
Yes.
What's your evidence?
It's just better every week.
See, I'm hearing a claim. I don't hear any evidence. Find some evidence. I
Or
like
you
to be.
sleep better, I don't know.
It's good to sleep in. Everyone's sleep.
All right. So, any questions about this information, this recap before we continue? So, don't forget, we need to learn to make arguments. We need evidence for our claims. My counter is, I'm not saying that you're wrong, but my counter would be is that when I wake up at 4:40, I'm alert and ready for the rest of the day. When I wake up at 4:40, I'm able to knock out the rest of my day and I don't have to work out.
Okay, what's how you
Last night I went to bed at 11.
And you wake up at what time?
We got 5 hours of sleep.
I usually wake up around 10 or go to bed around 10 or so and then wake up at 4:40.
You get like what?
I need some long
Huh?
sleep.
How many of you guys feel like some waking up phone?
Yeah, sleeps for the 6 to 7 hours, unfortunately.
I go to sleep at like 9:30 and I'm still waking up.
Yeah. I will say this, in y'all's defense, there is science to back up high schoolers need more sleep, but you can also go to bed earlier and wake up earlier.
I used to wake up.
What about people with jobs?
Huh?
What about people with jobs?
Well, people with jobs need to stop letting employers take advantage of them and not work every night of the week.
What if you can't?
What if I want to?
What if
Get a different job.
No money.
Okay, what if you don't work?
Look, legitimately, listen, hey,
So you got a job.
stop, hey, listen, I worked in high school as well. You should not let an employer take advantage of you and work more than 2 to 3 nights a week, preferably 2 during the week, and then work on the weekend short. But listen, hey, listen. Your employers are taking advantage of you because you're high school students and they can pay you less than they can pay other people.
I work 24 hours a week.
That's about right. I would say 18 to 24 is about right, but I wouldn't go much more than 24 with a
I was
full-time
doing
job.
35 hours a week.
Yeah, good. So, now Marshall, you also have you only go to school half a day, so it's more doable for you. But listen, legitimately, you can find employers, hey, okay, you can find employers who are not going to take advantage of you. And so if high school students stop letting employers take advantage of you, then they would have to change the way they do things. So make a stand and stand up for yourself and find an employer who's not going to abuse you. Hold up, you're not going to get fired if you're finding, Hayden, have I finished talking? Okay then. No, you started this. No sir, you don't tell me to calm down. Hey, don't go back to sleep. Engage in your learning. Listen, find a different employer, and if you can ask, and if they're not going to honor you working the amount of hours you need so that you can be a student and have a life as well, then find a different job on the side.
Where'd you work?
And hold on. Lots of different things, but we need to focus on math.
Yeah.
Okay? So, looking at this, activity 2.2, M3 dash, I don't know, 111. So it's just the next page.
Oh, you talking about
So, what? So let's look at this formula. Let's break this down because we're going to need this for the next piece. This is on page 111. So I'm going to break this formula down. I will not expect you to use this formula without, by the way, it's in the remember section right there. I'm not expecting you to use this formula without giving it to you because it's not a key focus, but it's going to help us learn about something that's important. And so I'm going to break this down for you. Let's talk about this. Let's say that you invest $100 in the bank or in the stock market, and let's just say you get a 5% return on your investment. Okay? So how much money are you going to make throughout the year if you get a 5% return on your investment?
5% return.
5% return.
On
For the whole
the-
year.
So you have $100.
Right.
And if you get 5% of that 100, how much are you gonna get? $5. So how much money would you have? Okay. So we're looking at our years. We're looking at our money. Starting with 100. At the end of 1 year, we're gonna have $105. Okay. Well, yep. Just a 5% return. That's one why you have to invest money consistently over time, and also why you want as high of a percentage return as possible. Okay, but let's look at year 2. So year 2, 5% of 105. Pick up a calculator. How are we going to find that 5% of 105? Yeah, but how do I find 5% of 105 in the calculator? Okay, so let me point this out. Say again. Not dividing by 0.5. Multiplying, but also not 0.5.
0.5.
So remember, a percent is per 100. So that decimal moves twice. So 0.05. Anytime you have a percent of, we're going to multiply. So what's 5% of 105?
$5.25.
$5.25. So how much money would I now have?
This every year?
Yep. Yep. Now, this is a very small investment. You'll see why I'm doing this in a second. All right, from here, what's 5% of 110.25? It's what? Well, it would be 5%, so 0.05 times 110.25.
What did I do wrong?
5 point, no, not even. Oh, never mind. It got too much numbers.
5.125. And so I add that 5.125. So notice, this is important to note here. Are you making the same amount every year?
Yes. No, I'm sure. You just increase about 0.25.
Is it though? Because that was a little bit more than 0.25.
It's sort of.
Sort of, right? So let me ask you this. What type of function is this?
Quadratic.
Okay.
Exponential.
Exponential?
It ain't nothing no.
You sure?
It's quadratic.
How about this? Someone said exponential. Let's check it. Let's look at our ratio. What's 105 divided by 100? The current divided by the previous. What? Come on, pick up a calculator. 105 divided by 100. So hit Control and Enter to get a decimal for me. You're good. 1.05. What's 110.25 divided by the previous 105? 1.05 again?
Yeah. So it is exponential.
Oh, so it is exponential. All right, let's check one more to make sure. 115.7625 divided by 110.25. 1.05?
I thought you were supposed to do the two numbers afterwards. You're supposed to do all of them.
Well, if you want it to be as accurate as possible, you need all of it.
Talk about investments, exponential.
So, well, that's the thing. Investments follow an exponential rate of return if we're talking about percentage yield. And so what I do want to point out is this. Where in the world did that 1.05 come from? But there's more to it than what was my percent yield every year? 5%. So where did 1.05 come from?
They're 5.
Why is it 1.05 then?
It just happened like that.
It don't just happen like that. Listen. Okay, say again. Something with 100? Let me ask you this. If you have everything there, what percent do you have? And then you gain what percent every year? So we have 105% of whatever was previous.
Oh, 5%.
So 1.05. It's not just because, like, everything in math has a pattern, it has a relationship. So I want you to notice something right here. P is your initial investment. That's the $100. Look what's right here. What is that?
1.
Representing what percent?
100.
That part of the formula is your 100% plus, so P, that's known as a, I should have written this already, a principal or initial amount. So if you want to break it down, I think it does the reminder, it says in the reminder, but that's where that's coming from, that principal or initial amount. I would also point out, that's the same as your what? Not a zero, not line of symmetry. Remember, if the x or the input is 0, that's a y-intercept. That's my y-intercept right there. 1 plus, what does that r stand for?
Interest rate.
Interest rate. What was my interest rate? 5%? Okay, we're going to talk about k in a second. Raised to, what's my variable here? T. So notice, if I substitute 2 in, how many times have I gotten that 105%? Twice. See how we would have multiplied by 1.05? Twice. If I want after 100 years, what would I do to figure out my amount of money after 100 years? Put on 100 for T. So this is why we want equations. It makes things nice and easy. Can somebody type in 100 into that equation and tell us how much money someone would have after 100 years of investment? Got a lot of people not typing stuff in.
You won't put the right there.
13,100.
Yeah.
I'll just approximate it there. Okay.
You gonna be dead by the time you get dead.
Yeah, with that kind of attitude. Maybe you have some
100
kids though, you want to leave that behind, right? So here's, hold up. Okay. I want you to think about something though. After 100 years, starting at how much money? $100 became 13,000.
You get a job.
So, say that again, Ethan. Can we change the starting value?
Yeah.
Can we invest money every month or every year and it goes up even more? Okay? So you never want to just invest once and leave it alone. You want to invest and keep investing. That's definitely true. But my point is it follows an exponential function. Hopefully we understand this equation. But there's a way to change things a little bit. If you ever go to a bank, you actually usually get your money in quarters, or like quarter of a year, not in 25-cent increments, not that thing. But when I look at this, what I want to point out is, what if I got 5% split up over four different time periods for the year? Would that change the amount of money that I get? Why do you think that? Let's investigate. So here's the thing, that 0.05 would become 0.05 split over how many? 4. Over 4, if we're talking about quarters, right? And then for 1 year, we're actually going to have how many investment periods?
4.
We're actually going to have 4. 4 times 1. Type that equation in for me. Let's find out how much we would have at the end of 1 year with that method. So you can just put that entire thing in. 105.225. So did we get more by investing more regularly? Yeah, it was only 105 before. Now it's 105.225.
So much different.
It's not much different, but it's still different, isn't it?
It's different.
It's different. What about for 100 years? Notice, right, that 5% would be split into quarters, and how many periods would I have now? 400. Would it help to have 400 investment periods instead of just 100?
Yeah.
Change that equation so that it's 4 times 100 in there. Let's see what it becomes.
$14,388.4.
I was saying, so 14,388. So that's almost $1,000 more dollars. Notice, have I changed the amount that I invested? No. Have I changed what my annual interest rate is? All I did was I split it over 4 time periods. And that's because what it is, you are actually getting 1.0125. But if you do that 4 times, that comes out to be higher than just 5%. That's what is happening there. So, what about if I do it monthly? What will happen? Will I get more money?
Yes.
Yes? Let's look at just 1 year, but investing monthly. Just 5% still. Investing monthly. What am I looking at? $116 over just 1 year?
Oh. Oh, Miss Count tripping.
I was like, did you do 12 times 1? I said, I don't think it came out to be 116. What does it come out to be? Remember, 12.
Oh,
So-
tweaking.
Look, we're splitting that 5% over 12 intervals of investment. And so how many investment periods do we have? 12. So 12 times 1.
100.417.
Impossible.
Whatever it is.
100.35.
That sounds closer.
Yes.
It has to be more than 105.225.
1,205.
I give up. Let's calculate, bro. But we put it in the.
Oh, was it 100?
Put 2.
Quick question. Was this 105.225 or .025? 225. No, y'all lied to me. It was 105.095.
Oh, we got more.
When it was quarters, it was .095. Now it's 105.
You didn't calculate this.
What was it? 116.
Yeah.
So notice, still was that more?
Yeah.
A little bit more. What about if we look at 100 years? Notice this would now change to 100 years. So how much money would someone have after 100 years of just splitting it over 12 months? How much? Just guessing? Not typing into the calculator? By the way, guys, remember you can go up, highlight the equation, bring it down, and just change the pieces you need to change.
14,608 songs.
14,000 what?
687.9.
So did we get more money?
Yeah. And the this is big by 5.
That's the end of 100 years, 14,000?
Uh-huh.
That's it?
Yeah, you gotta change that to 12.
Okay.
Okay? Now, listen. But guys, we talked about it. You need to invest every single month, not just every now and then. I think this is somewhere around 13,500. So notice, is it increasing when we split it up over more regular intervals or shorter intervals? That's the question I'm asking. It is increasing. What about if we were able to invest every single day? How many days are there?
365.
Okay.
Dang.
So, let's
Probably over there.
do 100 years at 306. Actually, let's do 1 year. Let's do 1 year at 365 days.
Can we change
Yeah,
that?
it's just about it.
Say it again.
Can we change that?
It's gonna be the same thing.
What are y'all talking about?
Yeah, I'm confused.
Y'all gonna make me mad.
Hey, let's focus on this math. Let's substitute that equation in. How much are we getting at 5% interest over 365 days? 105.126?
127.
127? Notice it's still increasing. Not by much, but it's still increasing. What about for 100 years now? You don't even have to think, you're just putting it into a calculator. It's not that much. We're going to be thinking in a second.
We didn't even get to the
Come on. Just putting stuff into a calculator. What's the next amount? Taisha, put the wallet down. 14,800 and what?
36.2.
So once again, did the amount of money increase? Yes. I do want to point this out though. It's still increasing, but is it increasing as quickly? No. It went up almost $1,000, then it went up about $300, now it's less than $200. There's a limiting factor. And that's what we're about to talk about. So if you can compound more and more and more frequently, you could even get to doing it secondly. There's a limiting factor. And this is actually where an important concept was first discovered, is with bankers in the medieval times, trying to figure out, hey, how much is the most that I could get out of an investment? At 100% interest rate, if I compounded it without ever stopping, infinitely many times, what's the most that I could get? And so, two things before we continue, I do want to point this out. We've already broken down R is my rate, T stands for time and what? Years. So what is K referring to?
The number of compounded periods per year.
That's it. Which we're reading that from the book, I assume. I was like, that language sounds perfect and familiar. So K is just compoundings, so number of compoundings per year. And guys, I could very easily give you this formula and ask you to substitute stuff into this and tell me what the output value is. So as long as you know what those symbols mean, this is a very easy question to get right on an assessment. You just have to know what each part means. That Peter principle is my initial amount, it's my y-intercept. R makes sense, it stands for my rate. Now I do want to point out, your percent needs to be written as a what? Decimal. I'm not putting it in as a 5, putting it at 0.05. If it was a 10% rate, you would put it in as 0.1, things like that. And then K is just the number of compoundings per year, T is time in years. Alright. So what we have done is we've kind of gone ahead and knocked out a lot of the concepts early on. We're now going to look at, and so like you can make a note to yourself that we just kind of did this together. We're going to look here at number 7 together as well. Alright, so they are breaking this down. Now, please notice, technically in this problem, how much money are we starting with? Alright, so number 7 says, imagine that Helen, that's this made up person, so I did my own setup, but Helen finds a different bank that offers her 100% interest. Never going to happen, but it'd be great. Complete the table to calculate how much Helen would accrue in 1 year for each period of compounding if she starts with $1. Just $1, okay? And so like this can get to be a lot larger if you invest more money, but we're going to start with $1. And so if there's only one compounding in a year, and she has $1, and she gets 100% interest, right? Then how much does she end up with? $2. That's it. She gets that $1 extra back. Notice semi-annually, how many compoundings are there in a year? 2. Thank you. And so we get this formula. Notice the initial investment, 1 times 1 plus the rate of 100%. Notice that just becomes a 1. Split over 2 intervals, 2 times 1 gives me $2.25. here's what I need us to do. I need everyone to type into their calculator this formula for quarterly. So how many investments is quarterly? 4. So everybody type that formula in. Tell me how much money we would get. What'd you get?
I got a spreadsheet. Okay.
2.44.
Oh, hit Control Enter to get the decimal. 2 point what? 2.44. And guys, we can end it at the hundredths because we are talking about dollars. But 2.44. Okay, so monthly, notice how many compoundings are there? 12. And so what would the formula be? 1 for the $1 times 1 plus
1 over 12.
1. Say that again.
1 divided by 12.
Thank you. Raised to
12 times
12 times 1. Okay, so let's type that in. Again, remember you can just go up and highlight, hit enter and change what you need to change. Say that again.
2.6. 1.
2.61.
Yeah. You said we just focused on
2.61. So is it still increasing?
Yes.
Yes. Notice early on it increased by 25 cents, then only 19 cents, then only 17 cents. So it's slowing down how much it's increasing by, but it is still increasing. Here's what I need us to do at this point. I'm going to have each group do a different one. Now notice, if we're doing it weekly, how many compoundings are there in a year?
7. 7 days in a week.
How many weeks are there though?
Oh, 4.
300.
Oh, in a tree. That's trying to win. Fuck up, man. 4 times what? 4 times 12?
52.
There you go.
If we did not know that there are 52 weeks in a year, you got to know that information, ladies and gentlemen. Yikes! Okay, how many, I'm glad I'm going over this then together. How many days are there in a year?
365.
Okay,
Nobody asking like how many.
how would I figure out? Alright, so here's one thing. Hey guys, if you've never seen this before, hopefully you've seen this in your chemistry classes. But there's a thing called a dimensional analysis table.
Oh, I can.
So 365 days, and now there are 24 hours in how many days? 1 day. So I want you to think about this. I just created a little fence here, but how should I set this up so that my units of days cancel? Because I need to divide by days.
Put it 1 day.
The 1 day needs to be where?
Right there, yeah.
In the denominator?
Yeah.
This table helps make sure that you convert your units correctly. Days divided by days, they cancel. Which then means that 24 hours needs to go up here. This is a skill that can help you on the ACT. Not only does it show up on the math portion, but it also shows up on the science portion. Creating a table like this to make sure units cancel correctly is a very, very, very useful skill. So how many hours are there in a year?
8,760.
8,000 what?
760.
Okay? So how would I figure out how many minutes there are?
Do the 365 24
So here's something I will point out. If you're just trying to come up with it on your own, it's pretty tough. But look at that table that I've already created. How many minutes are in an hour? 60? So should I set it up this way where there's 60 minutes down here and 1 hour up here?
Yeah.
Is that how it should be set up?
Yeah.
Why not? It doesn't match the other two. Notice, do my units of hours cancel?
Oh, no, you put the flip phone.
So notice, and that's what we need. We need 1 unit in the numerator. We need the same unit in the denominator. This is a quick way to check yourself. 60 minutes per hour. So how many minutes? Notice you got to, remember you multiply across, and then you would divide by whatever's in the denominator, but we don't have anything.
18,400.
18,400?
No. 365.
Just multiply these three.
Yeah.
If it's together, you multiply them out.
518,000.
518,000? 518,000, how much? 400? Now, I'm about to find out if any of us do any theater or have ever done any theater. How many seconds, huh?
Wait, you said 500.
Uh,
6 years?
5,600.
Yeah.
5,000,
525,000.
okay. I would say, that number didn't seem right. Does anyone know why I would know that that didn't seem right?
It's gonna be good, it's gonna be like shit.
No one seen the movie Rent? Or heard the musical?
It's okay.
Man, that was a big deal when I was in high school, but I also understand that
We're not.
I'm old.
Yeah.
But there's a whole song that is dedicated to how do you measure
Sing it.
the time of the year. First off, you never want me to sing ever.
Oh, we
I will
understand. You only
make
gotta
you
do
leave.
it.
Okay, so every second, how would I figure out how many seconds there are?
Cause there's 100 seconds in a minute. I'm just playing 60 seconds in a minute. I'm just playing.
So where would the 60 seconds need to go?
go?
So I do 60 seconds per 1 minute. Notice how my minutes cancel. So how many seconds are there in a year?
A lot of think it's 5,000.
No.
No, that was minutes.
3 million.
30.
Oh, my God, 31 million.
31 million?
536.
1,000.
That's it.
And that's it?
And 3 zeros.
You didn't put that on me.
So, I don't need the formula. Hopefully you know how to substitute into that formula. Group 1, I need you to do the weekly. Group 2, I need daily. Group 3, I need hourly. Group 4, every minute. Group 5 and 6, every second.
Mr. Kennedy, I just knew it.
Okay? Guys, it's just a matter of putting into the calculator. Yeah, it's just put it into the calculator.
Wait, we're doing this?
Yes? Yep. Look at what your group has to do.
71.
Yes.
Group 2, you're doing, yeah.
I need,
Yeah.
I need some reassurance.
You're group 3.
So all I do is just doing that.
Right, remember it's the number of compoundings per year, so there's 52 compoundings in a year, so 1 divided by 52, raised to the 52 times 1. You don't have to, but you can if you want to. But remember, it's just putting that 52 in place of the compoundings, that's it. When you, as a group, have come to a consensus, raise your hand and I will write your answers.
We run the hundreds, right?
Round to the hundredths, yes. Actually, I lied. Go to, because as far as we're going to have to go 6 decimals for me. Yeah. There's a reason why, I'll show you. So if you, actually, was it only go to 4 decimals? Do you know how to make it show more decimals? So if you highlight the number after it's spit out and you hit enter and bring it down, it'll show more decimals. It'll show out to like 12 or 20 or something like that. You might need to do control enter to get the decimal.
Oh my God.
We can write it.
Yeah, you can. So then hit enter. Write that out. Yep. That's why we want more decimals than just those. And so we'll get more decimals in a second. Because there are more decimals after that. That's why I was saying we want 6 decimals. Yeah. Uh-huh. Go write that number.
I'll do that.
Why not? Oh yeah, look. You didn't put that in the exponent. Might want that in the exponent. And then remember, hit up and highlight it and hit enter to get more decimals out to 6 decimal places. Yeah.
6?
Man, it must be really hard to write stuff, right? No thinking about it. You just have to like get it in the calculator and write it down.
Just the easy thing. I like it.
What is what? Remember, hit control enter to get the decimal. Okay. And then the up arrow, enter, so that shows you my decimals. Alright,
Hold on. Yes, I can't.
getting more decimals, what did we get to? 2.71. Now you should head to your group.
Yeah, why she over here messing with me? That was me. That was me.
So, group 2, what'd you get? 2.7. More decimals. 457. Okay? So I want y'all to look at this. Okay? Someone asked, like, why do they get the same number? Because math is the study of patterns and relationships. And so we see a pattern forming here. Okay? I told you that originally that it was bankers who were looking at investments, but a man by the name of Leonard Euler discovered that there is a limiting factor. Why do you look like that? What's the equation?
I said I heard it before.
Oh, okay. So, Euler found that if you continue to invest more and more frequently, specifically as k approaches infinity, right? So as k approaches infinity, this 1 times 1 plus 1 divided by k raised to the k approaches 2.71828 ... You're asking, why do we get the same answer? We get the same answer because as that k approaches infinity, this expression approaches a limiting factor. Because Leonard Euler was the first one to really define it and come up with it, he got to name it. And you know what symbol he used to define?
E.
E. This is the number E. This is known as the natural base. Because if you actually study nature, this base E is throughout nature, time and time and time again. If you ever hear about carbon dating, with figuring out how old artifacts are or how old dinosaur bones are, it is based on this idea of the natural number E and half-lives of carbon. The number E is known as the natural base because so many mathematical concepts are built on this limiting factor of E, whereas if things are breaking down infinitely quickly, if it has infinite compoundings, we get this limiting factor of E. And so if you look at the very next page, it talks here about the natural base. And so I would make a note to yourself that the natural base is referred to very heavily on the next page. It talks about it to a lot of detail. Notice I did not lie to you. Leonard Euler. It is a man that I started to really be impressed by, I guess, 5 or 6 years ago when I first started exploring. Yeah. But notice he discovered this at what age? 21. Now I gotta say, they didn't have TikTok back then to distract them, things like that. He also came from a very wealthy family, so he didn't have to worry about jobs and things like that. However, math was something very important. In fact, my wife showed me a quote which I think is very interesting, and some of you might find interesting as well. Snoop Dogg made a quote to, I don't remember what the magazine was, but in 2009 he made the statement that when he was in high school, he worked his way up from general math to calculus. And they asked him why. He said, well, general math earns general math money. He wanted to make more. So, thoughts to think about as you move forward in life. Leonard Euler took that to heart before Snoop Dogg was ever famous. And he discovered mathematical ideas time and time again. He wrote research manuscripts. And so we need to be aware of this natural base that's about to show up in the next lesson very heavily. You don't have to focus on the reasoning, but what I do want to point out to you is the last little piece of information here. So one, guys, you've got to know what E is and be aware of that background, where it's coming from. Because I can easily ask you, what is E and why does it come about, right? The background, the concept. Now, lesson 3, we are jumping to page 125. With just a couple minutes, I'm going to address 2 really important ideas. What key concept are we about to learn about? Logarithms. Which a logarithm, notice those key terms, logarithms are a type of what? Yep. Look at the name though of this lesson.
Inverse.
Turn to the inverse. A logarithm must be an
Inverse.
inverse. So look at the next page. I know we're jumping a little bit. But I want you to notice this. What function are we dealing with right here? Exponential. F of x equals 2 to the x, an exponential there. And when I look at that exponential, I see this notation. What does this notation indicate? That is the inverse function of f of x. And look at the inverse. First off, how in the world are they getting this inverse graph here? Transposing the x and y, the inputs and outputs, which comes from the reflection across. Does that look like a reflection to you?
Yes.
Notice what was a horizontal asymptote right here becomes a what right here?
Vertical.
Because what was an output became an input, right? Notice this idea of inverse is going to show up time and time again, but we have inverse function. Notice -3, 1/8 became what? 1/8 -3. What was 0, 1 became 1, 0. So, we haven't talked about it heavily yet, but I would need you to hear me very clearly on this. Logarithms are a thing that scares students year after year after year, but they don't have to. What is a logarithm? The inverse of an exponential. That's it, right? We know that the square root of 16 is equal to what?
4.
And we know that because 4, if you can learn your exponentials and understand these logarithms as the inverse of those exponentials, what we study tomorrow is going to be super, super, super easy. And we're just going to spend a couple days on these logarithms, but please be aware the number e is going to show up within the exponentials because e was important, or it's going to show up in logarithms because e was important for the exponentials. We're going to have to move a little bit more quickly tomorrow. Alright, some of us need to finish Matthew workspaces. I have started putting those in for people. I have gotten your understanding checks in. And some of us need to consider doing a retest, and you need to email me. Your parent needs to, sign you up for that.
Oh, no!
Yes, ma'am. What? When we take the test, it'll replace your mistake. When we take the test, it'll replace your So, remember, Trey, I always look at how you do on the test and replace whatever your understanding check grade was in the first place. So if you miss the understanding check and we go over it in class, you can't really make it up, but I'll just use your test to replace it. Okay?
I still got one. I got one like right here. I got one like this. Or like
did you look after yesterday? Because I updated grades yesterday. So check again. I think it brought your, yes, I actually remember that one. It brought your grade way up too. Yes, sir.
Are we meeting there?
I thought we said we were meeting Tuesdays from now on. Or Tuesday this week.
I have a meeting for ambassadors after school.
Man, how long though? Probably won't be that long.
We're picking our dates for summer, whatever we do.
Okay. So go to that, pick your dates, and come to that.
Listen, how you sign up for a weekend? You send it to my mama or our school.
I sent it to, I think, both you and your parents. I can send the email again though. But they have to respond to there's a link on the parent newsletter. Okay?
When's Matthew?
Wednesday.
You taking Wednesday?
The last retake is on Wednesday. Okay, be quick. Everything. Good morning, Kennedy. Glad to hear it. Good morning, Casey. Yes, sir. Good morning, Inslee. Good morning, Inslee. I can't hear you. Good morning, Inslee. Good morning, Inslee. Good morning, Inslee. I can't hear you still. What'd you say? I still can't hear you. Come on. Good morning, Inslee.